Bonjour. I'm Mr. Jeter, the astronomy teacher. My friend and wonderful colleague, Dr. St. Julien, asked me to put together a little bit about French astronomy. So, without further ado, let's start with the great Charles Messier. As you can see, Messier lived in the 1700s and early 1800s. And interestingly, Messier was interested mostly in comets, discovering new comets. Well, he made a list of objects, but the objects he made a list of were things that he wasn't interested in, things that were kind of in the way. And so, ironically, he became famous in the long run for this list of objects that he really wasn't that concerned with, things that had been discovered. So we call it the Messier List or the Messier Catalog. And to me, it's a bit of an all-star list. There are much larger catalogs. The Messier List is only 110 objects. So there are a whole lot of really famous things. Again, it's like an all-star list. You start with M1, the Crab Nebula, and everything, most of the things, at least in the northern hemisphere, that are very famous. The Andromeda Galaxy is M31. If you're into astronomy, you kind of know these things. The Orion Nebula is M42. The Pillars of Creation, the Eagle Nebula, M16. So they all have common names, but we also, if they're on that list, they have the Messier name, the M name. And they're about, again, 110 objects, and that's what he is most known for today. I want to mention Lagrange. Lagrange actually was born Italian, I believe, but spent the whole latter part of his life in France, so he worked for the French Academy of Sciences, I believe. But his most valuable contribution to astronomy, he was a mathematician, and he figured out some points around planets or moons or stars that we now call Lagrangian points. And it turns out that every planet, for example, has 5 of these special points. They're kind of like gravitational balancing points, if you will. So let's just take this picture here. At the upper left, you see the one that says the L1 point. Well, that would be between this, whatever this is, a star and a planet. And that's the point where the star's gravity is pulling one way and the planet's gravity is pulling the other, and that's the balancing point. Now, Lagrangian points, NASA loves these points because they're kind of stable. So if you're going to park a satellite around the Earth, guess what? You park them at Lagrangian points. It's kind of cool. So, for example, the Lagrange point between the Sun and the Earth, that's where we tend to put solar telescopes that are focused on the Sun. We're getting ready to launch a really incredible infrared telescope called the James Webb Space Telescope. And that's going to be parked on the opposite side of the Earth from the Sun. That's a spot we don't really use that often, which is kind of cool. It's also a natural gathering place, I should mention, for natural, moons and asteroids and things like that. So, for example, Jupiter, on both sides of Jupiter's orbit, it has a collection of asteroids. They're called the Trojan asteroids. NASA just recently launched a spacecraft called Lucy that's going to actually travel. It's a 12-year mission, so it's going to be a while, but it's going to go out and investigate those Trojan asteroids. Now, back to the point, those Trojan asteroids, guess where they're located? At the L4 and L5 Lagrangian points of Jupiter. That's just naturally where they collected over the history of the solar system. So these turned out to be very important points in understanding how solar system celestial mechanics works. So that's Lagrange. And I'll wrap it up here with Urbain Le Verrier. I love this story. Le Verrier did a few things, but the most famous one by far is discovering a planet. Do you know the planet there? Well, that is Neptune. Neptune was discovered in the mid-1800s. Now, the planet Uranus was discovered with a telescope in the late 1700s. Well, it turns out by the mid-1800s, they had enough data on Uranus to realize that its orbit was off. In the more official science speak, it was perturbed. There were perturbations in the orbit, and so Le Verrier did the math. And he figured out, okay, there has to be another object whose gravity is throwing off the orbit of Uranus. So Neptune, the planet Neptune, was discovered on a piece of paper. That is the power of mathematics. Now, Leverrier, by the way, sent his work to a German astronomer, Gall, who ended up actually finding it in the telescope. But Leverrier gets the credit because he discovered where Neptune would be and roughly how massive it would be and so forth, all with mathematics. Pretty amazing. And in case you're wondering, yes, the French are still heavily involved with the astronomy in modern times. This is one of my favorite observatories on the planet, Pic du Midi, and I don't know if I'm pronouncing that correctly, but it's located on the in the French Pyrenees, as you can see there. I think that's between France and Spain. Just gorgeous, just gorgeous. Of course, they're heavily involved with the European Space Agency and so forth. So, que magnifique when it comes to the French contributions to astronomy. So, with that, I bid you adieu.